Hello everybody, in this video we are going to continue our conversation about the different laws of exponents and how we're going to use them to simplify expressions. So in some of our previous videos we talked about vocabulary, but we also talked about two of our most basic rules. So remember that we have a zero exponent rule, which tells us anything raised to the zero power is an automatic zero and can be eliminated. The second basic rule that we talked about was the negative exponent rule, that if you have a negative exponent, then we can move it to the opposite side of a division or a fraction line, and it will change the sign from a negative to a positive. It also works backwards, so we'll talk a little bit more about why we would move a positive and turn it to a negative later on. Now the video for today is we're going to talk about the product rule. So when we're simplifying expressions, the product rule is basically telling us that we're multiplying numbers, but we're also multiplying variables with different exponents. So the first thing I want you to do is in your paper, let's go ahead and say multiply. So this is a multiplication problem. Now they don't always look like this. Sometimes they have a little dot to represent multiplication, but most of the time we see parentheses for multiplication in Algebra 1. So the first thing I want you guys to do, according to some of the rules that we talked about, the steps, is to look at your problem. If you identify that this is a multiplication problem, the parentheses tell me this is a multiplication problem, then that automatically tells me that I need to use the rules for the product rule. The steps for the product rule. So one of the most easy ways to remember this is that you're going to multiply your big numbers and you're going to combine your little numbers, which are your exponents. But before you do that, I'm going to ask you to organize your work. So even though these look like they all go together and these look like they all go together because they're separate parentheses, I want you to understand that nothing goes together. We can actually take these all apart and rearrange them to organize them. So the first thing I'm going to do is I'm going to organize these. And so I'm going to start with my coefficients. I have a -3, but I have another coefficient, which is a 4. So I'm going to put it right next to the -3 in parentheses, so we know that we're going to multiply the big numbers. The next thing I'm going to ask you to do is put all your variables next to each other. So I can already see I have two x's, x to the third and x to the second. So I'm going to take all the x's and put them next to each other. I'm going to do the same thing with the y's. I have y to the fourth and y to the -3. We're not going to worry about negatives right now because we want to put the y's together first. And then we're going to do the same thing with the z's. So we have z to the second and z to the third. So I took every single thing in both parentheses and organized it. Now I like to box my stuff. So I'm going to put this big box around it, and I'm going to keep the coefficients separate, the x's, the y's, and the z's separate. Because this lets me know I'm not allowed to have more than two of the same variable. So that means I need to combine them to make them one, because that's what my final answer needs to look like. So the first thing I'm going to ask you to do is we're going to multiply this. So we're going to multiply -3 times 4, which gives us -12. So we're done with the first box. It's been simplified. Let's do the same thing with our x's. As long as they have the same base, then you can take their exponents and combine them. 3 plus 2 gives us 5. So we have x to the 5th power. So both of those x's combine to become x to the 5th. We can do the same thing with the y's, but we're going to do it a little bit differently because this is a -3. So we're going to say 4 minus 3. 4 minus 3 is +1. So we combine the 4 and the -3 to give us 1. We now have 1y. Let's do the same thing with the z's. 2 plus 3, 5. Now this is where I want you to stop and look. We have one of each kind. We have only one x, one y, one z. No negative exponents, no zero exponents. This is my final answer. Now, one of the things that I do want to address is that this 12 is negative. But remember, this negative 12 has a positive 1 as an exponent. It's an understood 1 there. So because this is positive, we don't have to move the negative 12. We don't have to create a fraction, and we don't need to move it. This is my final answer as it stands. All right, let's look at the second one. Same thing. I have two sets of parentheses. That tells me that this is a product rule. This is being multiplied by this. So my first instinct is to organize everything. I have two coefficients, so we're going to say 3 times 2, which are these two right there. I can see that we have two x's, so we're going to say x to the negative 1, x to the 3. Two y's, y to the 4th, and because we have a y with no exponent, remember, understood 1. All right, then we have z to the negative 2 and z to the negative 3. I'm going to put my box around it and separate everything. All right, we have coefficients in the front, so we're going to multiply those. So we're going to multiply, I just realized I misspelled, multiply, there we go. All right, 2 times 3 is 6. Now we're going to do our x's, and we have a negative 1, and that's a positive 3, so it's negative 1 plus 3. X to the second. 4 plus 1 gives us 5. Negative 2 minus 3. Now be careful here. I don't want you to do negative 2 minus a negative 3. It is negative 2 minus 3. Use what's there. Don't add anything. Don't take anything away. And that's going to give us z to the negative 5. Now this is almost our final answer. Number 1, we only have one x, one y, one z because we combined them. Number 2, we don't have any zero exponents, but we do have a negative. So we do have this negative 5. So I'm going to go ahead and put a 1 underneath it, and I'm going to remind you that these are all separate. So I'm going to put the 1 over here actually. And so from here, this is fine because it has an understood 1. This one's fine because it's a positive 2. This one's fine because it's a positive 5. This one is not fine, so we're going to move it down because it's a negative. And if we move it across that division line, it is going to change the sign. So when I write my final answer, it's going to be 6x to the second, y to the 5th, over z to the 5th. Because when I drop that negative 5 to the bottom, it becomes a positive 5. I no longer need the 1 there because the 1 is just a placeholder. So once I move the z to the 5 down, I don't need the 1 anymore. This is my final answer. No negatives, no zeros, and 1 of each kind. All right, I'm actually going to stop right here because we just wanted to talk about the product rule. The next rule we're going to talk about is the power rule. How do we take an exponent and raise it to another exponent? So I'm going to show you how to do that. So I hope that these examples helped. Remember to look at your problem so you can identify the rule that you're going to use. Then you're going to organize it, and then you're going to simplify it and combine it, and then make sure that you have the correct final answer. All right, I hope these examples helped. I'll see you in the next videos.